know that. Okay, they're ready. All right. Our next presentation is on friction, and it is with Casey Liebrich, Zach Hilty, and Eddie Smith. So, gentlemen, whenever you are ready, we're ready for you.
Whoa, my foot is not sticking to the floor as it should. I wonder why this is.
Why, hello, Leonardo. I'm Gulary Antimons, and I have an explanation for your problems. It's because of friction! But friction is the force resisting the relative motion of solid surfaces, liquid layers, and material elements sliding against each other.
Did someone say friction?
Why, hello, Charles Augustine de Column. I was just explaining to Leonardo here what friction is. One of the most common types of friction is dry friction. Dry friction is the resistance of lateral movement between two solid surfaces. I myself know two laws to demonstrate dry friction. My first law states that the force of friction, F, is directly proportional to applied load, L.
For example, if I'm going to push this block of wood with my finger, the weight of the block contributes directly to the static frictional force and to be overcome to make it move. If I put this weight on top of the block, this increases the applied load, also called the normal force, which increases the static friction on the block, making it harder to move.
Exactly. Now my second law states that the force of friction is directly independent to the apparent area of contact. For example, if I place this block on its end, there's a smaller apparent area of contact with the table. But as you can see from this picture, the weight is focused on a more concentrated area. This concentration of force allows more surface molecules to be in contact with the table, giving the block a bigger true contact area.
If I place this block flat on its side, it has a larger apparent area of contact with the table. But, as you can see from this picture, its weight is more spread out. This causes it to have fewer molecules in contact with the table, so it has a smaller true contact area. However, the frictional force with either position is the same. I have to overcome the same amount of frictional force to get it to move. Miraculous! I also came up with a law that applies to dry friction. It is that the friction between two objects is independent of the speed at which the objects move. For example, if I'm going to rub this block of wood on the table, the speed at which I move it does not affect the kinetic friction on the block. Wow, I have thought and thought about this, but I've never really defined it. Now that I've heard a solid explanation about this friction, I think I've finally started to understand it. Now I know that there are two types of dry friction, static and kinetic. Static friction is the friction between two surfaces that are not fluid relative to each other, while kinetic is the friction between two surfaces that are fluid relative to each other. Wait, stop right there. You must remember that static and kinetic friction only apply to dry friction. I can't wait to learn more about friction. I am very excited. That's really great because there's so much more to learn and friction has so many details that you have to be very attentive.
You could not have put it better, Colin. Well, it's back to the grave for us.
Whoa, those guys really knew what they were talking about. But they forgot to mention the other types of friction. As they just mentioned, there is dry friction, which is the resistance of lateral movement between two solid surfaces. Fluid friction is the friction between two liquid or viscous fluids in contact. Lubricated friction is the friction where a liquid separates two solid surfaces, like oil and moving parts of a car engine. And skin friction is the drag, or resistance of liquid across a body. And internal friction. This is the force-resisting motion of elements making solid materials undergoing plastic deformation. From these types of friction, we're going to talk about dry and skin friction. To demonstrate static dry friction, we have set up an experiment that involves two phone books with interlacing pages.
Now watch carefully as we attempt to separate these two books.
Ready? Go! So what happened here? You just witnessed the power of friction! The friction between the pages built up so much that it was impossible to pull them apart by brute force.
The equation that represents this type of friction is referred to by many scientists as the fun equation.
This is the fun equation. F subscript F stands for the force due to friction.
U, the Greek letter mu, which is the coefficient of friction between two surfaces.
And F subscript N is the normal force. See? F, U, N. Fun! Here is a picture demonstrating the fun equation. Wow, that was a fun fact. Boom. And now for another one. Did you know that there is no friction in space? This is because there is a lack of gravity, and objects have no normal force, which is a major contributing factor to friction.
Now we have set up an experiment to demonstrate skin friction or drag. As you recall, skin friction is the drag, resistance of fluid across an object.
Now if you'll please direct your attention
over here,
we will be conducting our second experiment.
You'll take this bowl of water and spin one smooth ball,
A racquetball.
and one rough ball,
A tennis ball.
with approximately the same size and mass. Watch closely and observe which one spins longer.
Ready? Racquetball. Go.
Stop. We have 5.2 seconds.
5.2.
Success, success, success.
And now for the tennis ball. Go.
Go.
Stop. We have 1.7 seconds.
As you can see, the racquetball is go longer.
But why?
Well, on the tennis ball, there are small bristles allowed to have a greater surface area in contact with the water that causes drag, which induces friction.
As a result of skin friction, the smooth ball spun longer because there was less friction with the water, whereas the rough ball has a greater surface area which allowed the water to slow it down at a faster rate.
Right you are. Now we're going to do another demonstration about dry static friction.
This rig in front of me will demonstrate how static friction affects the angle at which a wooden block slides down a ramp. This is called the angle of friction. The angle of friction correlates directly to the coefficient of friction, which is the surface coating or grit of objects.
And to do this, we have 3 pieces of sandpaper with different grit. We will test each one. First, we have
240 grit,
sandpaper, and then
120 grit,
sandpaper, and finally
40 grit sandpaper.
we will test each one and measure the angle at which this wood block slides down the ramp first.
Initiating test 1.
Go.
Stop. We have 39 degrees.
39 degrees.
Initiating test 2. We have 47 degrees.
47 degrees.
And now for the 40 grit sandpaper. We have 59 degrees.
59 degrees.
Now, as you can see, the wood block slid at the greatest angle with the 40 grit sandpaper. This is due to the fact that the 40 grit sandpaper has larger grains, which make the block of wood have a greater coefficient of friction. Overall, there has to be a greater force moving objects on a surface with more surface grit.
The surface coating of objects has a large influence on how friction works.
Wow, friction is so cool, but I wonder what the world would be like with only a little bit of friction.
Well, friction is one of the most important forces in nature.
Without friction, you wouldn't be able to walk. Our feet would slip on contact with the ground. This floor has a very low coefficient of friction, which is why I didn't have to mention slip when we came into the room.
We wouldn't be able to drive cars, the brakes wouldn't work, and the wheels would spin out on the road.
We wouldn't even be able to lean on walls because the friction between the ground and our feet holds us up.
People would be slipping and sliding all over the place, and the world would be completely out of control.
Whoa, a world without friction would be dangerous. We hope you enjoyed our fun presentation.